All right, so today what we're going to do is we're going to talk about rational numbers, and what we're specifically going to talk about is multiplying, dividing, and a little bit of cross canceling. Now we're going to get into fractions because they're rational numbers, but first before we do that, we're going to go over here and we're going to talk a little bit about decimals because those are also rational numbers. I have a couple up here and I have a couple on here that we're going to kind of talk about real quick. First, let's talk about this. Remember that the product or quotient of two rational numbers having the same sign is positive. Just a little bit of a review for your sign rules. Okay? The product or quotient of two rational numbers having different signs is negative. Now remember, product is the answer to a multiplication problem. Quotient is the answer to a division problem. So that's really all they're talking about here. So, got a couple of problems set up. Find each product or quotient. 7.2 times negative 0.2. What they're doing is they're kind of referencing this and they're saying, oh, a positive times a negative is going to get us a negative. And most of us are going to plug this in a calculator and that's fine. But I'm going to show you how that algorithm really looks like here in just a second. And then over here they have like this more complicated division problem. I'm going to give you a little bit easier one so that you get to see that algorithm a little bit better. But if I get this problem, I'm plugging this in the calculator. Negative 23.94 divided by negative 10.5. A negative divided by a negative gets you a positive. That's what they're showing here. Okay, I'm going to show you the algorithm on how I actually do this multiplication division because I want to remind you of how to do it because we've probably been using calculators for a little while now and we may have forgotten how to do these algorithms. Okay, so I got this problem up here, 7.2, and notice that here I use the same problem because that's a good problem on how to show this, but we're going to show this, and we got 7.2 times negative 0.2. Guys, all we're going to do is set one up over the other, right? So 7.2 times 0.2, right? And this is a negative, so I know my number down here. This is multiplication, but this is a negative, so I know my number down here is going to be negative because a positive times a negative gets me a negative. I know my answer is going to be negative. So when I get done, my answer is going to be negative. That's what I know. Okay? And I know that before I ever do any kind of multiplication here. You have to know your sign rules so that you can recognize when you got the right sign or not. All right, so all I'm going to do is I'm going to go through here, and I'm going to take this 2, and I'm going to multiply it times each one of these numbers. So 2 times 2, 4, 2 times 7, 14. Okay? Now, this is 0, and any number times 0 is 0. All right? But let's say if that was a 1, I would come down here, I'd bring down a 0, and then I would multiply that 1 there, and that 1 there, and I would have that. So I'm going to show that just so that you can see it, right? So I brought my 0 down because I moved over a place. So I brought the 0 down. Now I'm going to take this 0 and multiply it times 2. So 0 times 2 is 0. 0 times 7 is 0. And then I'm going to add this all up. Okay? Well, 4 plus 0 is 4. 4 plus 0 is 4. 1 plus 0 is 1. Right? I'm showing how the algorithm actually looks. Okay? So now I'm going to do this. I'm going to go in here. I'm going to count how many numbers are behind this decimal. Well, I've got 1 here, and I've got 1 here. So I'm going to move the decimal on my final answer down here 2 spaces to the left because there's 2 numbers behind it. So 1, 2. So right there is where that decimal goes. And because this number was negative and this was positive, my answer is negative. Okay? So that's what that looks like. All right? So be aware when you plug it in your calculator, that's what your calculator is doing for you. Okay? Now, this one, you probably plug it in a calculator, but whatever. All right? So that's how you do the multiplication. Just a quick reminder of how that works. Let's look at the division. Okay? We need to be able to do this. Like, we need to be able to look at it and go, okay, I know how to do that. Most of us, calculator, we're going to plug it in. Fine. But you need to recognize it and understand what it's doing for you and how to do it. All right, so you got 8.25 divided by 0.5. Remember, the first number, when it's written like this first number goes in the box. Divide, right? So 8.25. 8.25 divided by So what we're gonna do is we're actually gonna move this decimal first. We're gonna take this, we're gonna move it here. Okay? But when I do this, I'm gonna take this one and I'm gonna move it here. Okay? However many spots I have to move it on this one, the one that's out here, I'm gonna move it on the one inside here. Okay? So I get 5 divided by 82.5. And now I'm just going to go into my division. How many times does 5 go into 8? Well, it goes once. 5. Now I'm going to subtract these. 3. And then I'm going to bring this down. How many times does 5 go into 32? 6. Because 6 times 5 is 30. I'm going to subtract that. I've got a 2. Then I'm going to bring down that next number. And I know that this decimal's going right there. Okay? So I bring this number down. And then I looked up here and I went, oh, wait, my decimal, it needs to go in there. Okay, so I put my decimal up there. Now, how many times does 5 go into 25? It goes 5 times. 5. 0 remained over. Here's my answer, 16.5. Both of them were positive, therefore this number is positive. That's how you do this division. And all I'm doing is I'm showing you this algorithm just to give you that reminder of how to do it. Okay, so that's what we're doing. All right, so now let's take a look and let's talk about fractions. Okay, now you need to be able to multiply fractions. You're not always going to be putting it in the calculator because sometimes it's easier to do it without the calculator, to be perfectly honest. All right, so multiplying fractions. So I put up fraction right here, and I even gave you the answer before we did it, right? Equals 2, 6. So what you're going to do when you multiply fractions, there's a couple of different methods that you can use. This one's the easiest, but the others are going to help you on more complicated problems, so we want to know how to do those too. Okay? So you have 1/2 times 2/3. All you do is multiply the numerators, multiply the denominators. So 1 times 2 gets you 2, and 2 times 3 gets you 6. Okay? So multiply the numerators, multiply the denominators, but when you get a number like this, you have to reduce all your fractions. You can't just leave fractions unreduced. You have to do that. So 2/6 reduces. You're going to divide each by 2 because 2 divides evenly into the top and the bottom. That's what you're looking for, a number that divides evenly into the top and the bottom allows you to reduce. So we're going to reduce by a number that divides into both. Divide by 2, divide by 2. Well, 2 divided by 2 gets you 1, and 6 divided by 2 gets you 3, and that doesn't reduce. There's your answer, 1/3. Okay? So, one way, multiply just straight across. Probably the easiest way to do it. But you may have to reduce at the end. So if you're not good at reducing, we need to get better at it and make sure we can do that. Okay? The other thing is that when you're multiplying, remember the commutative property, if I can say it correctly. Commutative property. Okay? You get to rearrange some things with that. Okay? So what I did was I took that 1/2 and that 2/3 and I just rearranged the top numbers, right? Okay? Because really what this is doing is this. 1 times 2 over 2 times 3. And I got to rearrange it, right? Now you can split that up, but that's really what's going on here, okay? 1 times 2 is 2, 2 times 3 is 6. You end up with the same thing. But here, look, when we rearrange this fraction like this, okay, and we say, oh, well, we got 2/2 and 1/3. 2/2 is really just 1, right? So really what you have is you have 1 times 1/3, okay? And I got that from here. This is me showing you what I did here, okay? And now this 1 I got from looking at this 2/2, which is 1. That's what I got, how I got that, okay? So that's what's going on so that you understand what you're looking at, okay? But 1 times 1/3, 1 times 1/3 is 1/3. Okay? That's what that is. All right? Now the other way, and the way that I actually prefer, right? I'm not a real big fan of this one. It does work, and you should understand what you're looking at, but I like this one a little bit better, the cross cancel. Okay? It's the same, it's really the same thing, but it's the way that I prefer it. And it's also called reducing early. So cross cancel, reducing early, depends on who you're talking to, what they're gonna tell you. Cross cancel is the most common form, all right? So 1/2 times 2/3, and what I'm gonna do is I'm gonna look and I'm gonna say, okay, is there a number that can divide evenly into the top and the bottom somewhere along there? And this only works if it's multiplication. Just like this only works if it's multiplication, okay? So this only works if it's multiplication. So I'm looking at this and I'm going, okay, is there anything that can divide evenly into the top and a bottom number? Well, I've got a 2 here and a 2 here. Well, 2 divides into 2, right? So 2 divided by 2, 2 divided by 2, okay? And these is what we call, they cross cancel. Say it correctly, cross cancel. 2 divided by 2 becomes 1, 2 divided by 2 becomes 1. And now I'm just gonna keep looking to see, does anything else do that? No, okay. Well, 1 times 1 is 1. 1 times 3 is 3. Now I've reduced early. Now guys, understand, these are simpler problems than what you're gonna be using when you cross cancel. Cross cancel, you're really gonna use that mostly whenever you have bigger numbers that you can reduce them and make it easier to multiply across, okay? And make that reduction at the end easier. This one you're probably gonna do this method with because it's easy to reduce at the end. But sometimes you're gonna have bigger numbers that are not easy to reduce at the end. So make sure you can do this. All right, moving on. We have 3/5 times -1 and 1/2. Mixed number. You cannot multiply a fraction times a mixed number. You must turn it into an improper fraction. It doesn't work if you try to do it the other way. So we have to turn this into an improper before we can do anything else. So we're just gonna rewrite it. 3/5 times negative, it's still negative, right? And I'm gonna take this, I'm gonna multiply it times here, and then I'm gonna add it to this. So 2 times 1 is 2. 2 times 1 is 2, plus 1 is 3. 3 over 2. Now, I'm gonna check, does anything cross cancel? No. So now I'm just gonna multiply straight across. 3 times 3 is 9. 5 times 2 is 10. Positive times a negative gets me a negative. Here is my answer, -9/10. Okay? That's really all there is to this. And I already had this up here. I'm gonna move that off there so that you can see what I did. Okay? So, -9/10. It's a good answer. Over here, 3. Now look, 2/7, and okay, so remember, parentheses directly up against number, multiplication, but they may show it to you like this, where it's the dot. Okay, I prefer parentheses, but a lot of textbooks use the dot. Sometimes they use the parentheses. We're no longer using the X. Don't do that. Okay, I actually suggest you not use the dot either because sometimes it looks like a decimal. But you have 2/7 times 1/4 times 4 and 2/3. You're multiplying them all together. It's all multiplication. Okay? So what I'm going to do is I'm going to come in here and I'm going to change this mixed number to an improper fraction. That's one of the first things I'm going to do. Okay? So I've got 2/7 times 1/4 times, and I'm going to multiply 3 times 4, 12, and I'm going to add it to the 2, 14. 14 over 3. Now, I showed you the cross-cancel method. This is where that cross-cancel method comes in really handy. Okay, when you multiply multiple of these, we want to get these fractions where we can deal with them. All right, so the first thing you're going to notice is, hey, this 2 and this 4, they reduce. It's one of the first things I would have noticed. because 2 divides evenly into the 2 and the 4. So, divide by 2, divide by 2. That becomes 1, this becomes 2. Okay, pretty straightforward. Now the other thing that you notice is, oh wait, I've got a 14 over here. Well, that goes into the 2, or it goes into the 7. Well, I'm going to use the 7 and the 14 because that's the biggest number and it's easy to deal with, right? But you could use the 2, it works too, okay? So here, 7 and 14, this becomes 1, this becomes 2. Okay, but now, look, I can do it one more time. The 2 2's, okay? 2 divided by 2 becomes 1. 2 divided by 2 becomes 1. And now, I'm going to multiply them all together because I can't reduce anything else. 1 times 1 times 1 gets me 1. 1 times 1 times 3 gets me 3. And now I don't have to reduce at the end because I did it all right here. Okay? Now, could you have multiplied this all together? Yeah. But you're going to have a bigger number and you're going to have to figure out what goes into it. And you're still going to end up doing this. It's much easier to do it here than it was over here. Okay? So that's cross-canceling. Right? And remember, you can only cross-cancel when it's multiplication. All right? That's the only time you can cross-cancel. All right. Let's talk a little bit about dividing fractions. Dividing fractions, we're going to use the thing called a reciprocal or a multiplicative inverse. Now, all that is two numbers whose product is 1. So when you multiply two numbers together, you get 1. Well, for a fraction, the multiplicative inverse or the reciprocal is when you take that fraction and you flip it over, okay? Because what happens here is 3/8, the reciprocal is 8 over 3, right? So 3 times 8, and I even have it down here so that you can see it, right? The reciprocal of this, 3/8, is 8/3. So 3 times 8, it's going to get you 24, and 8 times 3 gets you 24. You can also look at it as it crosses out, 1, 1, 1, 1, and it gets you 1, right? Because 24 over 24 gets you 1. Okay, this is a key concept that you have to know in order to be able to divide fractions, because we're going to be using this. All right, so reciprocal, the reciprocal of a fraction, you just flip it over. You don't change the sign. That's what I have here. Negative 3/8, because a negative times a negative is a positive, so you don't change the sign. Right? Negative times negative gets me positive. 3/8, 8/3 equals 1. That's what we're talking about there, okay? So all you do is if you're looking for the reciprocal or the multiplicative inverse, because they're going to use both terms, okay? They're going to use both of these terms for this definition. It's two numbers whose product is 1. It's a really key concept. Got to know this. All right? All you do is if you got a fraction is you just flip it over and you keep it signed. All right? That's what you get here. All right? So, 4. Now, I'm just going to show you some examples of this on how to work these problems. This is all how you divide. Okay? So, 2/3 divided by 1/3. The way you divide fractions is you actually multiply by its reciprocal. You don't do it to the first number. You keep the first number what it is. 2/3. But I take this 1/3 and I'm going to flip it over and I'm going to multiply it by it instead. So I've got 2/3 times 3 over 1. That's what we do. Okay? Now, a lot of you guys have seen this before. That's great. But you got to be good at it. Okay? Because you're going to see this constantly now. Okay? So 2/3 times 3 over 1. Now look here. Those reduce. Those cross cancel. Look, that becomes 1. That becomes 1 because 3 divided by 3 is 1, and 3 divided by 3 is 1. I found a number that divided evenly into both those numbers, okay? Then I'm going to multiply straight across. 2 times 1 is 2. 1 times 1 is 1. That's an improper fraction. Be aware, sometimes they're going to ask you to turn it into a proper fraction or a mixed number, okay? So 2 over 1 is 2, and right there's your answer. Okay? Any number over 1 is that number. So number 5 we got here, -1 1/3 divided by 2/3. We got a couple of steps here, okay? First, we can't do this. We can't divide by this mixed number. Second, we're going to multiply by its reciprocal over here. So we're going to take this, we're going to turn it into an improper fraction. So 3 times 1 is 3, plus 1 is 4, so you got 4 over 3, and it doesn't change the sign of it, it's still negative. Negative. All right, we're going to change this from division to multiplication. Keep, change, flip, that's the other way that they say it, but it's really just multiplying by the reciprocal. Okay, -4/3 times 3 over 2. Okay, and then again, we've got that same setup that we have over there. That becomes 1, that becomes 1, but look here, 4 and 2, that also cross cancels. So let's do that. This becomes 1 because 2 divided by 2 is 1, but then 4 divided by 2 is 2. Okay, and then I'm going to multiply straight across. 2 times 1 is 2. 1 times 1 is 1. But now I had a negative times a positive, which gets me a negative. So I got -2 over 1, which is -2, which gets me my answer. Okay. A few steps in there, but they're not bad. None of them are bad. Now, could you have just multiplied 4 times 3 and got 12, and 3 times 2 and gotten 6? Yes. And then you could have reduced. That would have worked. It's fine. Right? Make sure that you get really, I would strongly suggest you get good at cross canceling because you're going to see it a lot and it's going to help you later on. All right, so 4 divided by 2/7. Okay, I've got a whole number here divided by a fraction. Take and turn that whole number into a fraction. Okay, so 4 over 1 multiplied by the reciprocal, 7 over 2. Okay. Now you can reduce here, 4 and 2. But see, I do this reducing early because it's so much easier, right? 2 divided by 2, 4 divided by 2 becomes 1, becomes 2. Notice I'm not marking on this original problem here. I rewrote it so that it was easier, and I can look back at the original problem if I had to. Okay. So now I'm going to multiply straight across. 2 times 7 is 14. 1 times 1 is 1. My answer is 14. All right? You're going to see that. All right? Here's the other way they're going to show the division. All right? This is -1/3 divided by -1 1/5. It's the same thing as if you wrote it like this. And I actually, when I see this, I like to rewrite it when I'm dividing fractions. Just because I see the cross cancels better and I see everything that I need to do to it. Okay? So this is the same thing as that. It really is. And since I don't mess with the original problem, rewriting it like this is not that big a deal. Okay, so I got -1/3 divided by -1 1/5. Okay, so I've got -1/3 times, because I'm going to change that to multiplication, but I got a mixed number here, so now I've got to change this to an improper fraction. So 5 times 1 is 5, plus 1 is 6, so this becomes -6 over 5, and then I'm going to multiply by its reciprocal, so now I'm going to flip this over, and I get 5 over 6 here. Okay, so change it first, then multiply by the reciprocal. I kind of skipped a step there, I shouldn't have. Okay, so do that. So now I'm going to get rid of that, and now I've got -1/3 times 5 over 6, and negative times a negative is going to be positive, so I know my answer is going to be positive. 5 times 1 is 5, 6 times 3 is 18, so I've got 5/18. Okay? If you have a hard time with any of this, let me know. Especially if you're stuck on the improper fraction, mixed numbers, because you're going to have to be able to convert them back and forth between the two with some of the stuff that we use. If it's just you turning in a paper to me, an improper fraction is fine. But some of the stuff that we use, ask you to put it in proper form or mixed number form, and you've got to be able to do both of those. If you're struggling with cross-canceling, come see me, I'll help you work with that. I mean, really, if you're struggling with anything, come see me, I'll help you, all right? Let me know if you have any questions.